Hello everybody, I'm showing you my hydroponic basil. I have 12 pots of basil. Each pot is inserted in a bucket. This is a typical Kratky or deep water culture setup. I have 12 buckets which are connected to a main control vessel. All those buckets are 10-liter buckets. This vessel is a 20-liter bucket. The connection between the buckets are by means of hoses. I have only those two large half-inch hoses. The rest of the hoses are small diameter hoses, maybe 3-4 millimeter hoses. With this type of connection I can control the water level, just controlling the water level in the main vessel. If I want to increase the water level in all those buckets, I just need to increase the water level in the control vessel. If I want to discharge the water from those buckets, I just need to discharge it from this vessel. So it is a very easy setup. As you know, Kratky system is very reliable, especially for those kind of crops. Basil, lettuce, leeks and so on. Let's have a look at the system. As you can see, the roots are extraordinarily white. This means that the plant is quite healthy. I just lay it down here temporarily. So you can see this is the 10-liter bucket. Let's have some measurement of pH and microsiemens. .6. And (2100 microsiemens). The high value of pH is due to the system itself. Just please do consider that this system is an outdoor system, and this means that anytime it rains, the rains will fill the bucket, and as a consequence water level rises up. The second consequence is that the pH will increase due to the rainwater. And the third consequence, the rainwater, which has a very low value of conductivity, will dilute the existing water and will bring down the overall conductivity value. Anyway, even if I have a high value of pH, the plants are still doing very well. Let's see how the system is made. As you can see, the main item are the buckets. I have a main vessel, which is a 20-liter vessel. I started painting it with black paint, but the spray bottle finished, so I left the bucket, the painting unfinished. But as soon as I buy a new bottle, new spray bottle, I will cover also this surface with black paint. After that, I will put this bucket into a white bucket, excuse me, in order to prevent heat from going inside the bucket. Here, each of those buckets with basil have this kind of design. I have a black bucket which contains the nutrient solution. This bucket has been painted black on the outside, on the outer surface. Then I inserted black bucket into a white bucket. So I have two barriers. The first barrier is the white barrier, which reflects the heat. And the second barrier is the black paint in the first bucket, which prevents the light passing through the walls. Okay. I have half-inch hoses, but because I had only 4 grommets, I could use only 2 half-inch hoses. The remaining pipes are small pipes. I mean, they are maybe 2, 3, 4 millimeter hoses. I'm using a 5-inch, I think it's a 5-inch pot with expanded clay. As you can see, I made by myself all those holes with a drill bit. I didn't drill the holes, I just overheated the drill bit on the oven, on the fire of the oven, and then I melted those holes. So this is a handmade solution. Okay. I'm quite happy with this layout. As you can see from the light, this part of the garden is in full sunlight, so it receives a lot of heat, a lot of light, but in any case I don't have any problem with the roots. I mean, I don't have issues with the root nutrient solution temperatures. This system, for this system I didn't do major jobs. I mean, in these 2.5 months, I only refilled the system twice, but I never controlled the pH and I never controlled the conductivity. This because I have one philosophy. The philosophy is plant the plants and let them work. You don't need to work. You must not work for the plants. The plants must work for you. As you can see, even if I have a high value of pH, the plants are doing well. So this is not really critical. Let's talk about future improvements. I would like to change all those hoses, not those two hoses, but all the remaining hoses, and change them with larger hoses, because now it takes quite a long time when I need to fill all the system up, or when I need to discharge it. It takes quite a long time because of the small diameter hoses. But when I have all the hoses like these ones, so when I have all the connections made with large diameter hoses, the loading and unloading of the water will be, I don't say instantly, but almost. So that is innovation number one. Innovation number two, here I have two, I don't know if you can see them, I have two overflow holes. When the water, when the rainfall, when I have rain, the water increases in the bucket, and those two holes act like an overflow. So I cannot suffocate the roots of the basil. I would like to increase the diameter of all those overflows. So that is improvement number two. Improvement number three, as you can see, I have holes in the lids. I did some experiments, some trials, and I left the lids with holes. Actually, that is a bad idea, because having holes in the lids means that the light can easily pass through, but the light is, let's say, a minor issue. Even if I have some algae growth inside, I don't really care about that. The main issue is that open holes means breeding ground for mosquitoes, and certainly you don't want clouds and clouds of mosquitoes in your garden. So that is improvement number 3. Improvement number 4 is white lid on top of black lid. Improvement number 5 is I would like to put a floating valve here. Do I really need a floating valve? No, I don't need a floating valve. Why I want to put a floating valve here? Just for curiosity, just because I like to have, let's say, an almost perfect system. But please don't misunderstand me. This is not a perfect system. This is a handmade system. But anyway, I would like to make it as automated as possible, with easy automation. So I would like to have a floating valve and a reservoir which feeds this control bucket. By the way, I forgot to say that I can control the level of the basil bucket, the water level, by doing mainly two things. The first thing, I can very easily add or remove water from the main vessel, or I can also lift the vessel up or bringing it down by just removing those two bricks. Improvement number, I don't remember which number, maybe 5 or 6. I would like to make this layout work in a recirculating way. What do I mean? I have here another 20-liter bucket. This actually has nothing to do with the basil, but I just put it here just for explanation. At the moment the system is working like this. The water goes from this bucket to those two buckets, and from those two buckets goes to the remaining buckets. In the future I would like to add this bucket here, and I would like to connect the last 10 buckets with this bucket. That means that water goes from here to those two buckets to the 10 buckets, and from the 10 buckets to this bucket. Then I will put an air pump with very low flow in order to lift some water from here and pump it over to this bucket. In this way I will create a difference in level. This level will increase and this level will decrease. By doing so I will push water from this bucket to all those buckets, and I will draw water from those buckets to this bucket, and I will create a recirculating system. I think this will improve quite a lot the situation of my actual layout. Let's see what happens. One more remark concerning the material. Whatever system I will show you today or in the future, just bear in mind that the material that I'm using is always food grade, or at least I try to choose food grade materials. Water solution is to be considered like food, therefore all those buckets are food grade buckets. The yellow hoses are food grade hoses. The black grommet, actually I don't know, I think it's rubber. I don't have certification, food grade certification for the grommet, but I think that rubber is not a problem for the quality of the system. On the internet you see many people using PVC. Actually I'm a little bit reluctant using PVC. I had a difficult choice when I had to design my strawberry system. I couldn't find food grade PVC. Well, actually I found one supplier for food grade PVC, but it was a company, a factory which was not near my home, and they required I order a minimum quantity of pipes, and I also had to pay for the transport, so it was not really cost effective. So I just changed the system. I didn't do the strawberries in a PVC pipe system, I just did it in a Kratky system. Anyway, you see many people on the internet using PVC, especially for the strawberries or even for NFT systems. As I told you, I'm a little bit reluctant, but that is my personal point of view. I don't want to correct anyone, I don't want to teach anyone anything, but this is just the way I do hydroponics, because I don't want there is the slightest chance that the plants might absorb some bad elements that you can find in PVC, like lead, for instance. Since this is a hobby, since I enjoy doing hydroponics, I don't want to poison myself, my family, my kids. That's the reason why I try not to use, I try always to use certified material. But as I told you, this is my personal vision of hydroponics, and I respect all any other people who do in a different way. Okay, let's draw some conclusion. The system is very reliable. In 2 months I didn't do anything, so I am quite satisfied with the system. Actually, I did not expect any surprise, since for this type of crop, as it is for lettuce or leek, for this type of crop the Kratky system is really good. You can do a system like this, which, let's say, is a little bit complicated, but just because of the hose connections. But if you don't want to do a system like this, you just can keep it simple. And as I showed you in my first video, you can do a system like this. Basil inside one bucket. That's it. That will work fine as well. Just up to you. Okay, I thank you for the attention. I wish you a good day and happy hydroponic growing. Bye bye and see you next video.